Hi everyone, and it's absolute pleasure to be here today and talk to you. So today's topic, as you can see here, is boost your AI with quality data, and we're gonna talk a lot about data. So let me first introduce myself. So my name is Magda, and I work as a data evangelist at Toloka.ai. Prior to this, I have worked in data science field as an NLP engineer, developer, and a data scientist. So this is my background. I also have been involved in teaching and mentoring data scientists, and I contribute to Medium publications such as Towards Data Science. So you can find me there as well. And why we're gonna talk today about data and data labeling. So I work for Toloka, and Toloka is a company that provides different ML services. And something that we do really well, and we have a lot of history in, is data labeling itself. And we've been doing it over 10 years. You can see some brands we've been working with previously. And I'm going to share some things we have learned during this time working with data. So let's see our agenda for today. So we're going to start with talking about different challenges that we encounter in AI and data science. I'm going to present a solution as we see it. And the solution here is crowdsourcing. And then probably the largest part of this presentation is showing you different data labeling pipelines that will show you real industry case studies. So I think we can get started on this. So if you look at this graph, and I believe many of you work either as data scientists, ML engineers, or some type of data engineers connected to AI. So you might be familiar with this graph here. It's been thought that AI products are usually built on three big pillars. And those are hardware, algorithms, and data. And the first two pillars, I grouped them together on this slide. This is because these pillars have been vastly explored in recent decade, let's say. So if you think about hardware, we can think here of things like storage, cloud storage, computing power, etc. And there are some really good solutions in these pillars, such as AWS, Azure, Google Cloud, and you probably can name a few more there. And the same happened to algorithms. Actually, data scientists were crazy on introducing different algorithms, different architectures, and pretty much using those right now become a commodity. You basically import some kind of a library, you tweak a few parameters, and it's available to pretty much everyone. So think about libraries such as PyTorch, TensorFlow, Keras, Scikit-learn. So commodities right now. If you think actually about this third pillar, data, it's not so easy to come up with so well-known solutions or established processes. Actually, I think it's still maybe a year ago where people start shifting to focus a bit more on this pillar. I think it's like a year ago that people started mentioning things like data-centric AI, and G started talking about it. It's become public, and there is definitely more hype about it now, but for some time it has been left outside there. And this is actually what we will be focusing today, so this data part. And additionally, I would like you to look at this graph here. So this is a graph that has been published a few years ago in Forbes, and it basically I can summarize it by saying that data scientists spend most of their time, and this is around 80% of the time, processing, cleaning, and managing data. And this is kind of irony. If you look at the previous slide, if you think that it's something that has not been looked on for so many years, and that actually data scientists find very challenging and have to spend a lot of time on. So ideally, in this data part, we would have some processes, tools that would establish basically some ways we should deal and manage data to basically reduce this time. I don't know if you guys agree with this. Maybe you can, if you want, you can comment how long you think you spend on actually those data connected issues at your work. I will read maybe the comments at the end. And we can go to this one again. And also, if you are a data scientist, you definitely have heard about Kaggle, and probably many of you might have competed in Kaggle competitions. However, what happens is the real world is very different. In Kaggle, you compete within a given data set. Basically, what you have to do is tweak the model, tweak the parameters, build a different model, etc. But in ML production pipeline, there is so many more components involved in it. And basically, people who can manage this process can make better AI products. So it's not only the algorithms. And that's why if you look at ML pipeline, this is a simplified version of ML pipeline. And you can think that we usually start with training an algorithm. We do some kind of validation, comparing maybe different types of algorithms. Once we are happy with it, we push it into production and we monitor our model. And in case it needs, we retrain it. So this is a simple version of this ML pipeline when you create ML products. But actually what happens is that many of these steps, or maybe even all of them, required some human effort in them. And it's not just a small amount of effort. It very often might be really on large scale. So depending on your problem, the revised ML pipeline could look like this one. So here you can see that we start with the training, and I have added a human icon on every step. So in order to get some trained data, if you do supervised learning, you often need some labeling. The same happens for creating validation data sets. And then imagine, as I said, you push your model into production. So how do you know your model is doing well? Usually you have to source some labels again that you can compare your model's prediction to. And you already see, oh, my model has drifted. So what do I do now? We retrain the model. And obviously more data is needed. So I want to also share this one. So what is crowdsourcing in this context? I told you about the problems and especially data labeling. So if you think about crowdsourcing, think about basically it's thinking who should annotate this. Imagine that you are working as on some computer vision project where you have to label some data with bounding boxes. So who should do it? And what we propose is you actually could use crowdsourcing. So what does it entail here? You have a huge task, which is labeling a big data set. Imagine you have thousands, millions maybe of images. Basically, you distribute this task into different smaller tasks and distribute it over a crowd all over the world or the locations that people live in order to gather the answers from different people and then somehow aggregate it to have a solution to your initial problem so that your data set would be labeled. So this is how the crowdsourcing would work in this context for us, ML. And how it has been done previously, or maybe how some smaller ML teams do it. A lot of people would have either ML engineering labeling some data, or maybe finding an domain expert to label data. And this approach usually can be pretty expensive because expert knowledge, you have to pay more, and especially if it would be ML engineer labeling it. And I think it's usually hard to measure and especially hard to scale. So obviously, if you have millions of images, you need to create a whole data labeling scheme, and it just becomes really hard to scale this process. So that's why we believe that crowdsourcing in this case could be more economical, easier to measure, and is definitely easier to scale. So basically needing more labels means distributing more tasks. And also how it looks from our perspective. So how does it look for data scientists ordering this kind of labeling, or ML engineer like requesting this data annotation? So we become a kind of a manager that designs the data labeling pipeline, and we are on the top of this pyramid. We might aid ourselves with some experts' knowledge, but our expert in this case maybe do not label our data, but create training exams that are further distributed to test how well our actual labelers, who are theoretically unskilled workers, are doing our tasks. And on the bottom of this pyramid, we also have ML classifiers. So this is definitely the case where you can add, if you have already labeled enough data, you can add some ML algorithm to help you to some extent to label some parts as well. And we would be basically designing those pipelines. And this is also, I wanted to show you the contrast, how it looks from the perspective of a person who is doing the labeling. So if you kind of follow the original labeling approach, where people just sit on the desk, maybe work for a big retail company where they have to label loads of data, they just do routine tasks, annotate those maybe products with their colors or whatever is needed there. This is usually very routine, and because they work for one company, the tasks are usually not very diverse. So we believe that this changes also from the perspective of the worker. If he is a crowdsourced worker, he has a chance to work from the comfort of their own home. He can choose the tasks he's working on because he have access to platform where people from all over the world can upload different tasks, different problems. He actually might have more chance to work on something that he's at least to some extent interested in. And basically, we call this process as management of people by doing engineering tasks. So it requires really minimal effort from people. And thanks to automation, API, and SDKs, we can actually treat this crowd as another computing cluster. And this is something I'm going to talk a bit more at the end. And once we actually have access to the crowd, and we already have the pyramid I have shown you on the other slide, you can think that our process changes into 4 simple steps. So this is visualizing creation of the data annotation. project. The first step is choosing the crowd. So because you have access to crowd that is everywhere, theoretically everywhere in the world, you might choose at least some basic characteristics you would require them to complete. So they might need to speak a certain language. They might be in some age brackets. Maybe you need a specific gender to do your task. Maybe they need a particular device that needs to be used to do this task, etc. So those are very basic information about the user. There is something actually last one that I added here. They might be also subject matter experts in some specific skills that our platform can provide as well. And once you have chosen your crowd, your task is to train them. So remember, they are theoretically unskilled people. They are general crowd. So you need to explain them very well what they are doing. You need to explain edge cases. You need to give them detailed instruction. You have to explain them how you're gonna pay them for the work. So you can add things like paying people a bit more if they do their work better, etc. So this is the part when you train your crowd and explain things how they can need to be done on your task. And then we have a third step in the process. So you already have your people, you have trained them, they are doing your tasks. But obviously your project might go for days, weeks, and you need to observe the quality of this person, not only on the entry. You want to observe the quality of their work throughout the whole project. So the most common way of doing it is creating control tasks. And those are basically tasks that you already know the answers to, and you mix them with normal tasks so they are undistinguishable for people to see. And what you basically do, you measure how well they are doing on control tasks. And if they fall below certain threshold, you can remove them from the project. And they are also some kind of more basic quality control rules that you can establish, such as behavioral checks. You might check how long it takes them to complete your answers. Imagine that if they need to read a text and it would take maybe 20 seconds to read it. If they answer in 2 seconds, it's probably very unlikely they are doing it right. So there are other measures that you can also take control of it here. And then the last step is actually aggregating the results. And often in crowdsourcing, we send the same task to several people. We call it overlap. So instead of sending a picture, for example, for annotation to one person, we send it to 3 people, or maybe even 5 if we would like to be even more confident about the answers. What we need to do at the end is somehow take all the answers together and aggregate them to see what is our final labels. So in crowdsourcing, basically, we would have these 4 steps here that I have just shown you. And so this was a theoretical part, and I think this is the more interesting part, which are case studies. I think I have prepared around 5 case studies from different industries. And before we see them, I just want to show you how versatile this labeling industry is. We're going to see details about 5 case studies, but I just put on this slide more problems, more annotation problems that we are dealing with at our company. So the first case study I had prepared is search relevance. So let's just start with what search relevance is. It's basically evaluating search results. So imagine someone is looking for a product, he puts a search query, and then some item is returned. In this case that you can see, someone is searching to buy jeans, but has been shown a t-shirt. And what we ask person to mark here is if this answer, this returned item, a t-shirt, is relevant, not relevant in this case. Obviously, I simplify this to explain there might be more choices available depending on what kind of search evaluation you are doing. It doesn't have to be only pictures. It could be websites, so search engines, or some other product-related search tools. And why do we do this? So normally, if you're working on search relevance projects, usually you train ML algorithm to do it, and you already have something in production. However, your data is constantly added, it's changing quickly, so you always kind of create new versions of the algorithm. And ideally, you really don't want to you don't want this to be seen by your product user. So what you would typically do is you would do offline evaluation of the algorithm before pushing it anything close to online testing. And this offline evaluation is exactly, you saw the example of such offline evaluation in the previous slide. And only the algorithms that perform better than the one that is already in production will be rolled out to online evaluation. And this is actually when people might be able to see it, click on it, and you can gather more data. But this offline evaluation is actually a really important part. And this is actually when the humans are involved. And this is where you can use the crowd using the template you have seen before. And then I would like to take an example of another case study here. And this comes from the self-driving car industry. And so imagine that you are training a computer vision algorithm that needs to discover obstacles on the pictures on what camera is seeing. So what you need to do is you probably need to gather millions of images with marked up data, such as like pedestrians, other cars, streets, traffic signs, etc. So how it can be done? So your final results are what you want to be done is you want all objects to be highlighted with polygons. And how we usually design it is we divide those into smaller steps. So we create an annotation project for each object or specific category we want to mark. So in this case, we want to mark roads, transport, and people. Every of these objects would have its own annotation project. And in this project, we would ask someone to draw a bounding box around an object of interest. Then what we do is we want to check if this person have done our marking correctly. And again, we were working on high volume projects. So we have a lot of data. We don't want to do it ourselves. We don't want to check the bounding boxes. We need to ask the crowd here. So we create a second project, which is basically a validation project. We just ask if there is a mistake. And if they mark that something is wrong with the annotation, it needs to be re-annotated. And if there is no mistake, we actually can, we believe that this is correctly annotated picture. So basically, this how it could look like in the project. We have a picture on the left, the initial one, and then on the right, we actually have it annotated with traffic signs in bounding boxes. And this is actually a more formal version of this pipeline that you saw before. There is actually one project I added here, and depending on your case, it might be needed or not. And this is the first project here. It asks actually if the required object is present in the photo. So imagine that you want to label cars, all cars that are in the photos, but if 50% of your photos do not have any cars, you're just wasting time. So if you expect this to happen, we always suggest to set it up the first kind of validation project. If then from this first project, the data that is already, we know that this object is existing, may flow to the second one. This is actually the meat of our annotation. This is when people draw the bounding box. And as I said previously, this then flows to a third project. And the third project is a validation project where we ask people, hey, is this bounding box correct? If this bounding box is correct, we think our photo is annotated correctly. And if it's not, we need to resend it for annotation. And what we can do here is reconsider payment for people who actually did annotation for the projects in the second project that were incorrectly annotated. We can, if they did really bad job, we can actually not pay them, for example, for those. So you can see this is an example where this initial photo flows through 3 different projects to gather a final result. And I want to show you now another case study. It comes from the audio transcription industry. So what do we want to do here is we have recording. Imagine you work with bots. You want to understand human speech. So you have a bunch of recordings and you need to have them transcribed. Recording has to be changed to written text. So below here, you can see an interface, how you could set up a similar project. You could have a recording uploaded to a platform which people can play, start and stop, and you would have a transcription text below where they can type what they hear. So this is basic speech-to-text annotation. And how we usually do it is this way. So I mentioned that we always recommend people to provide training. So the first step is training and selecting performers. And then we usually divide such a recording. Imagine if it's 10-minute recording, we divide it into single sentences or maybe 2-3 sentences max. And these blocks are then given to individual transcribers, our crowd. And we do not give this, we give the same audio to several people. And what we are looking here is we are looking for k-exact matches. So again, in transcription, maybe 2 exact matches would be enough. And again, depends on the length of the text or audio you are transcribing, etc., and the confidence you want to achieve. So you can actually decide on the K, but you're just looking for a couple of almost identical transcription, then you believe this is transcribed correctly. So this is how you could solve this problem. And then this leads me to another case study. In this case, it's audio collection. And it can sometimes be a solution to a previous problem that I've just told you, audio transcription. In previous case, we had recordings already, but imagine if you did not. You could basically ask people to read the text and record themselves. Then you would just gather the audio itself and the written text, because this is what they have been told to do. So this is an example of such a task as well. So the interface would typically have some box where you can press and start the recording, or maybe you record it outside the platform and then you drag the file. You have a phrase that you have to say. In this case, it's others have tried to explain the phenomenon physically. And then you have interface, maybe where you can play this recording and check if this is correct. This is more or less how the interface for such a task would look like. And this is something we've done. And we worked with the voice assistant when we have had to gather different recordings of the same phrase. In this case, it's "Hey, Alisa," but imagine we recorded different type of phrases. So we just send it to 10, 20 different people to record "Hey, Alisa." And we would also set up a validation project, again, where a person would see both the phrase and the recording, where they could validate if the recording is correct. And the final result was just a bunch of recordings that we could then train the speech recognizer. So another thing that we've been working a lot is translation, and translation in many different contexts. It could be just translation of simple text. It could be translation of some product-related text on some e-commerce website. So there could be different tasks you could set up here. And this is just a typical example for computers, for data scientists. It's text to text. We have just text in some source language. So I love surfing in this case. And then translation in a different language. So we have Spanish, French, and Polish here, just to see how the simple task looks like. And typically, this is the pipeline we use for such tasks. So before even people can take part in our project, we should test their language proficiency. So if they claim to be fluent in French, you might need to check it. And this is actually interesting because depending on what you need, they need to speak both languages, the source language and the target language. And usually they need to speak better target language, even the source one, where because you want to make sure the translation is natural, etc. And then the project one is actual where the translation happens. So this is when they see the interface, they have the source text, and they have a box to input the translated text. And then we apply a validation project. You can see this validation project appears almost in all our pipelines. So this is actually where different people validate if the translation is correct. And usually, or depending if there are problems found, again, this kind of circles back. If there is a problem with translation, we just send it to retranslate it to another person. And we have actually a lot of experience in this translation industry, and Toloka was used in comparing automatic machine translation system for one of the international conferences. And I think I have an interface exactly how it looked like. So just to point your attention here, we did not do the translations, we evaluated the translation systems. So in this case, we had a source text. You can see a source text here in English on the left, and we have two candidate translations on the right. And a person has to decide how well this translation has been done. They can basically use the slider for each one of them. And they actually presented with more than one, so they can compare and see which one is better than the other. And this is actually what visualizes this pipeline that was set up for this project. So before people were allowed, they had to take a language test, and only a fraction of the people would pass it and go to the exam phase. In the exam, again, they would have to prove they speak this language, and only after meeting those criteria, they would be able to evaluate the translation. So they would be shown the things you just seen on the previous slide. And throughout the whole process, we would evaluate constantly the quality. So we would have some control tasks. We would have some translations that we would know what is our ideal answers, and we would compare them to what actually our annotator is doing and scoring how well they are doing on them. If they fell below 80%, they would be kicked out of the project. And then we have a step of aggregation of the results. And I have actually here on the right-hand side, you can see the actual test. They had to pass in order language test to pass to take part in our project. So you can see they had to just know some basic geometric symbols and do some maths here, but it's kind of probably if they don't speak the language, it's hard for them to do this. And as a result, you can see we translated many different language pairs, and we had over 600 users that took part in it. And you can see some language pairs we did are, let's say, kind of common. Let's say Chinese, Czech, German, Japanese into English, or Russian, French into German. But we also translated some very rare languages, at least for me, they are rare, like the last one, Xhosa to Zulu. Sorry if I'm reading it wrong, I'm not sure how to spell it. But this is kind of what also proves here that crowdsourcing works is we can find people having these weird or unusual skills, and we have access to them pretty much immediately. And then this is the last case study, if I remember well, that I have prepared for the day, and it's a bit different. It's content moderation. So it is something we deal a lot. And as everybody pretty now needs content moderation. So let me just give you two different maybe examples, what you could moderate. Imagine if you have like a service such as Medium, where authors from all over the world can provide content. Well, ideally, you don't want to read maybe all the posts, see all the pictures that are uploaded, all the videos. You need an algorithm to maybe do some moderation for you. And the same if you have any basic product, you might advertise it online and sell it online. People are able to give reviews. So you ideally would moderate this content if someone is putting some spam links or they actually doing bad comments, etc. So moderating content is very common, and usually it is done using ML algorithms. And obviously, to train those ML algorithms, you need the labeled data. But this is actually not what I want to show with this example. With this example, I assume you already have a machine learning algorithm that is ready. But the content usually in such cases is changing so fast that somehow this ML algorithm is not very good at it. And if usually those ML algorithms would provide you some confidence level, how confident they are about their answer. And if this confidence is below certain threshold, you could include additional layer in your pipeline. And this would be basically having a crowdsourcing project set up. And once this threshold is not met, the task would be sent for real human to moderate. And usually this is pretty easy for humans to moderate, even if they know the general rules. Even unseen data types can be moderated. And obviously, that way you have this second validation. And additionally, you can use it again to retrain your ML algorithm in the future. As you can see, this was already my last example that I have prepared for today. And I just would like to mention a bit about the data labeling automation. And you can see some of these pipelines are more complex than the other. A lot of can become even more complex that you have seen. And ideally, you'd automate them, not set them up and from scratch every project and then manually transfer data from one project to another. You want it to flow. So usually what can be done is the user interface, instructions, etc. Can be done using GUI, and probably it's easier to do it using GUI, but the rest ideally would be automating. So filtering performance, starting and stopping pulls, so starting and stopping annotation, and gathering the results. And ideally, all this data flow from one project to another, and this can be done thanks to providing API. So Toloka, for example, provides you with the API, and this is actually what I have been talking before. This is when you can use people and crowd as a computing cluster, basically have it automated in your data labeling pipeline. So at Toloka, we have an API, and it's wrapped up in two different SDKs, Java and Python. And I just wanted to show you how some of this could look in the code. So this is definitely not a deep dive, but once you actually have a connection, you have access, you are authorized, you can basically use Toloka client to open and close pools, get all the answers for the project, etc. So that was actually the last point I wanted to talk about today. So let me summarize what we've been talking about. So we started about talking about problems in AI and problems connected with data, how data is currently a bottleneck to many AI products. Then I told you like a bit of theory about crowdsourcing and how it can be an effective and scalable approach. And then at the end, we spent most of the time looking at different case studies. So I think that has been it. Also, if you would like to try Toloka, we have a promo code for you. If you want to use it, you just register on toloka.ai as a requester, and you can put this code Jutomate. This is the code for you to use it. And also, I believe we will have time for questions later, but if you don't get a chance to ask me what you want today, feel free to join our Slack. You have a QR code here, and I'll be able to answer some questions maybe that have been missed today there as well. So thank you, and yeah, let me see if you guys have any questions, and let me see if there was any comments about the data annotation that I have made at the beginning. Yeah, Crystal just said that she agrees that she does a lot of data cleaning and organizing data. Yeah, I don't know, Crystal, how you measure the time, but you say it's around 80%. So yeah, it's a lot. Guys, any questions?
Guys, last chance to ask questions before we wrap up. Okay, should you have any questions, follow-up question, please feel free to send it to me and we'll be happy to send it to Magdalena.
Yeah, that would be great.
I would like to thank you for your lecture. It was very nice, well organized. Naturally, all the content will be uploaded to the community website with the video and the slides. And we'll be happy to host you again should you have any more content you wish to share with us.
Oh, thank you so much. It was absolute pleasure to talk to you guys. Oh, I see the question now. I see there are some open source kits. Is that easily to start up with? Yes. Can you put the community website here? Thanks. Let me just answer both. So yes, I can put the community link here. I'm putting it right now. This is the link. And if it's easy to start up, I believe it's relatively easy. I can send you a link right now to a basic project. Toloka kit. If you want to start, it's obviously a learning. This is the easiest way to start up. It's in the form of Jupyter Notebook. I'm sharing it right now. This is how where the basic of data labeling using Toloka kit is explained. There are some more complex examples you can check out later, but this is the basic one. And as I said, it has some learning curve. So imagine, I guess you guys know pandas, or yeah, let's say pandas is a library that is difficult to use for data scientists. It's probably not easy for someone to use that doesn't know it. So I guess it would be kind of similar. You have to learn the basic first. Okay, yeah, thank you. Thank you again.